Welcome to Data Communications and Networking 2. We're going to discuss about access control lists for our pre-final lesson 2. So our objectives: 1. Creating an ACLC or access control list, matching an addresses, wildcard masks. We will be also discussing activating AZL, configuring standard numbered ACLs, extended numbered ACLs, creating named ACLs, and implementing Ipv6 Acls. Okay, definition and introduction. Access control lists are filters that enable you to control which routing updates or packets are permitted or denied in or out of a network. They are specifically used by network administrators to filter traffic and to provide extra security for the network. ACLCs provide a powerful way to control traffic into and out of your network, and this control can be as simple as permitting or denying network hosts or addresses. You can configure ACLC for all routed network protocols. The most important reason to configure ACLs is to provide security of your network. However, ACLs can also be configured to control network traffic based on the TCP port being used. Why use ACLs? Limits network traffic to increase network performance. ACLs provides traffic flow control by restricting the delivery of routing updates. It can be used as additional security, controls which type of traffic are forwarded or blocked by the router. Ability to control which areas a client access. So here is the list of the ACLC number ranges. For this discussion, we will be only included the standard ACLs, which range from 1 to 99 and 1300 to 1999. Second, we will include also extended ACLs, which ranges from 100 to 199 and 2000 to 2699. And we will also be discussing the named ACLs. Okay? Standard access control list. In earlier days, simple filtering was sufficient. Standard ACLs are used for normal filtering. Standard ACLs filter the packet based on its IP source address. Standard ACLs create filters based on source addresses and are used for server-based filtering. Address-based access lists distinguish routes on a network you want to control by using network address number or the IP. Example of command syntax for configuring a standard numbered IP ACL is r1 config hashtag access list 1 to 99 permit deny source address and source wildcard. Okay? The first value 1 to 99 specifies the standard ACL number range, and the second value specifies whether to permit or deny. So we'll choose only one from these two choices, permit or deny, to configure the source IP address traffic. The third value is the source IP address that must be matched. This is the source address is equivalent to the IP address of the one we will be denying or permitting. And the fourth value is the wildcard must be applied to the previously configured IP address to indicate the range. So we will use wildcard mask to specify any accepted IP address part. Next, we have the extended access control list. To mitigate current security threats, advanced filtering is required. Extended ACLs takes this responsibility. Extended ACLs can filter a packet based on its source address, destination address, port number, protocol, and much more. Extended access lists create filters based on source addresses, destination addresses, protocol, port number, and other features, and are used for packet-based filtering for packets that traverse the network. Example of the command syntax for configuring the extended numbered IPAZL is router config hashtag access list 100.199 permit deny protocol source wildcard operator operand destination address destination wildcard operator operand establish. So like the standard ACLs, the first value 100.199 specifies the ACL number range. The next value specifies whether to permit or deny according to the criteria that follows. The third value specifies protocol type, IP, TCP, UDP, or other specific IP subprotocols, and the source IP address. Then wildcard must determine traffic source. Masks are used with IP addresses in IP ACLs to specify what should be permitted and denied. Masks in order to configure IP addresses on interfaces start with 255 and have the large values on the left side. For example, IP address 172.16.2.14 with a 255.255.255.0 mask. Masks for IPAs are the reverse. For example, mask 000.255. This is sometimes called an inverse mask or a wildcard mask. Note this ACL's equivalence or ACL equivalence. The source wildcard of 0.0.0/255.255.255.255 means any. The source wildcard of 10.1.1.2/0.0.0 is the same as the host 10.1.1.2. If you subtract 255.255.255.0 normal mask from 255.255.255, it yields a 0.0.0.255 mask. The command below defines an ACL that permits this network 192.168.1.0.0.0.255. Access list ACL permit tip 192.168.1.0.0.255. We can also have access control lists that are named. Named access control lists allow standard and extended ACLs to be given names instead of numbers. Unlike in numbered access control lists, ACLs we can edit named access control lists. For example, configuration, we have R1 config hashtag IP access list standard inside in. So the inside in is the named access control list. Then we can go inside the access control list to identify or to set the configuration for the inside in named access control list. So we write hashtag 10 permit 10.1.1.0 0.10.0.255 and then hashtag 500 deny any log, and then after configuration we enter hashtag exit to exit the configuration. Then the following will be used for the verification of the access list configuration by executing the show access list command. Okay. IPv4 ACLs examples using standard, extended, and name. For this example, we have a network diagram, and we have three in the diagram. We have three routers. We have cut, RAID, and SAM routers. So we have the outside, we have the RAID as in the middle router, and the inside which is going in. This is an example of the use of a standard ACL in order to block all traffic except that from source 10.1.1.x. So the outside label means the packet is going out, and the inside level means the packet from this router is going in. So for the standard access list, we will use the 1-99 and 1300-1999 for configuring the interface Ethernet 0/0. So we have the IP address example 10.1.1.255.1.255.255.0. IP access group 1 in and then we write in a command prompt access list 1 permit the IP address and the mask address. Using the extended access list, we will have the same network diagram example, but we will be using the interface internet 0/1 instead of the internet 0/0. IP address 172.116.1.2 and then the mask subnet mask address. And we write IP access group 101 in 101 deny ICMP any 10.1.1 IP source and the wildcard mask and then echo. So this is the example of configuring the access list for the extended using the extended type of ACLs. Now we will be using named access list for the third example. So we write interface internet Ethernet 0/0 interface and IP address, IP source address, and then the normal or standard mask. And then we write the IP access group ABC in. The ABC is the name of the access list, and then we go inside the ABC access list to configure it. And then we write permit TCP host 10.1.1.2 host 172.16.1.1 and EQ telnet. So in writing Ipv6 Acl as explained with examples, there are similarities in operation and configuration of Ipv6 Acls and its predecessor Ipv4 Acls. If you are familiar with the basic operation and configuration of Ipv4 access control list, you will find Ipv6 Acls is easy to understand and configure too. The only difference is just the Ipv6 addressing. Ipv6 has only one type of ACL, which is comparable with Ipv4 extended name ACL. Ipv6 uses the Ipv6 traffic filter command to perform the ACL's function, unlike Ipv4 that uses the command IP access group to apply ACL to an interface. So Ipv6 has its own traffic filter command compared to the Ipv4 IP access group interface. Ipv6 ACLs do not use wildcard mask. Instead, the prefix length is used to indicate how much of an Ipv6 source or destination address should be matched. So this is an example of the ACL's Ipv6 Acl configuration. No? So we have one router and we have one switch or hub, two switches and hubs, and then we have two devices or hosts. So to use the Ipv6 access class command to apply the ACL to the BTY lines, we use the following commands in the CLI or command line interface. I configured hashtag Ipv6 access list no telnet permit TCP host. So we use the MAC address to indicate the source and destination of the IP addresses that we're going to permit. And then we type exit. Then again we type line BTY015 for the access code or the configuration code, and Ipv6 access class no internet in again, and then exit. And this command will set up the Ipv6 Acl configuration. Ipv6 configuration Acl has a verification method to use in the configured router, no? Showing the access list command. This will display both Ipv4 and Ipv6 Acls configured on the router. To verify all Ipv6 Acls configured on the router, use the show Ipv6 access list command, and this will display all configured Ipv6 access lists and their name. So R1 hashtag show Ipv6 access list will display all the access list no telnet, and also the one we configured in the example, the permit TCP host and the MAC address of the source and destination IP address that will be permitted or denied. So that's it for our so these are the general guidelines for the access control list, whether you are using IPv6 or IPv4. Okay, and this is the summary of our lesson. So this will be the pre-final lesson 2 of data communication and networking 2.